Okay, so turn to page 1 in your Chapter 11 packet. We are going to start out by learning how to graph square root functions. Now, this is the parent square root function, y equals the square root of x. So normally, when you don't know what a function looks like, we usually just make a table and we pick values, and I usually tell you to pick -2, -1, 0, 1, 2, etc. So let's see what happens when we pick these values. So -2 is the first one. So, well, what's the square root of -2? And then I go, uh-oh, there is no square root of -2. So I shouldn't have picked that number. How about the square root of -1? Again, there is no square root of -1, so I can't pick that number. What's the square root of 0? Square root of 0 is 0. Square root of 1 is 1. And now you might understand why I decided to pick 4 and 9, because although, square root of 2 is approximately 1.41, we don't necessarily go around knowing the square root of 2 or the square root of 3. We know the square roots of perfect squares. So I pick 4, and that's 2. I pick 9, and that's 3. So let's see what this looks like when I graph it. So now I'm going to graph 0, 0, 1, 1, 2, 3, 4, 2, 5, 6, 7, 8, 9, 3. And that's what my square root function looks like. Okay, so it's interesting to note here that there is a vertex, that there is a point at which it starts right here and it doesn't go continuously in both directions. So this vertex happens to be 0, 0. Now, when you know your vertex is 0, 0, that helps us come up with a domain and range of this function. Now, we did do domain and range, let's say, for a parabola. And we know that the domain was always all real numbers, but the range was either above a certain point or below a certain point. Now here, for square root function, your domain is going to be x is greater than or equal to 0, and your range is going to be y is greater than or equal to 0. And it's not a coincidence that your vertex is 0, 0. That's how we came up with it. Now, something else I want you to be aware of. We had an absolute value function. It looked like this: absolute value of x minus h plus k. And with that, we had a vertex of hk. Then we had a quadratic function in vertex form, and it looked like this. And we had a vertex of hk. Well, this is what the square root function is. It's y equals a times the square root of x minus h plus k, where hk is the vertex. So it looks very similar. We find the value underneath the square root with x, and we use the opposite of it for the x value of the vertex, and then whatever's on the outside is the y value of the vertex. So let's go back to our parent function. So this parent function is really y equals 1 times the square root of x minus 0 plus 0, right? If we put it into the form of y equals a times the square root of x minus h plus k. So in this case, we know h equals 0 and k equals 0, and that's how we get a vertex of 0, 0. Okay, so that's the parent square root function. Now, we're going to take what we know, and we're going to compare these to the parent function. We're going to state the vertex and the domain and range and the type of transformation. So let's look at this first example. If I go to put it in the form of y equals a times the square root of x minus h plus 1, I see that there's a 0 with the x, so that's a 0, and a 1 here. So I know my vertex is 0, 1. That means my domain must be greater than or equal to 0, and my range is greater than or equal to 1. Okay? Now, what kind of transformation occurred? Well, if the only thing that happened, we know a is 1, so if the only thing that happened was the vertex changed,